All right, so we proceed with this question. So this question says, using trigonometric identity for tan a plus b, prove that tan 3x is equal to 3 tan x minus tan cubed x over 1 minus 3 tan squared x, where x is not equal to 2n plus 1 multiplied by 30 degrees, where n is the number of integers. n is a member of integers rather. Okay, so we proceed. Let's solve this one as fast as we can, so that next time when we meet, we just begin a new tutorial sheet. Okay, so the first one here is tan 3x. So the first thing that you need to know here is the trigonometric compound angle formula for tan a plus b. So tan a plus b, let me write it here. I don't know if it's going to fit. Okay, let me just use white and write it on the screen. So tan a plus b, so tan a plus b is simply just equal to, so we have tan a plus tan b, then everything over 1 minus tan a tan b. So tan a plus tan b is equal to, tan a plus b is equal to tan a plus tan b over 1 minus tan a tan b. So this is the trigonometrical compound identity for tan a plus b. So let us quickly try to see how we can solve tan 3x using this same formula. So 3x can also be written as, so if we say 3x can also be written as what? 2x plus x. So I'm going to write tan 2x plus x there. And then I'll put it in the identity there. So on top, I'm going to have tan 2x plus tan x. Then everything divided by, so everything will be divided by 1 minus tan 2x tan x. So having written this, we know that we can also expand tan 2x using the same identity. So tan 2x, so 2x can also be written as what? X plus x. And this is now going to be equal to tan x plus x. So tan x plus x will therefore be written as on top. Okay, let me write it independent first. So I'm going to write it tan x plus x can also be written as tan x plus tan x, then everything over 1 minus tan x times tan x. So when you simplify this, simplifying this is going to give us tan x plus tan x. On top, we're going to have 2 tan x. Then down there, we're going to have 1 minus tan x times tan x. This will give us what? Tan squared x. So if this is what, if this is what you have as your tan 2x, so let me even change here. If you want, you can now write tan 2x, because x plus x gives you 2x. So tan 2x can also be written as that. So what is tan 2x in this expression? What is tan 2x in this expression, and on this part and on this part? I'm going to replace with this expression. So what this means is that my tan 3x will become, what is tan 2x? I'll put this part. So I'll have 2 tan x over 1 minus tan squared x. And then from there we say plus this tan x there, plus tan x. So I'm going to say this is over 1. Then everything over the denominator there, we have 1 there. And then we say minus. What is tan 2x? I'm going to put this same expression. So I'm going to have 2 tan x there. Then everything over 1 minus tan squared x. Then we're multiplying this with what? Tan x. So after doing the multiplication, this is now simple and straightforward. You multiply this and that. So tan x, 2 tan x times tan x there, this will give us what? 2 tan squared x. Okay, let me start with simplifying the numerator. So when you simplify the numerator, you find the common denominator there. So the common denominator will be 1 minus tan squared x. So this will be 1 minus tan squared x. Then when you say 1 minus tan squared x into 1 minus tan squared x, the answer is 1. 1 times 2 tan x, you get 2 tan x. And then plus 1 into 1 minus tan squared x, this will be 1 minus tan squared x times tan, you're going to get plus tan x plus tan cubed x. So this will be tan cubed x this side. Okay, I hope you can see. And then on the denominator, when you simplify the denominator, you're going to discover that you're going to have, let me just do it quickly. So when you find the common denominator there, because when you multiply this and that, you get tan squared. So on this part, you're going to have tan squared there. Then when you find the common denominator will be 1 minus tan squared x. And then on the numerator, you're going to have 1 into this expression. You get that same expression. And then this into that is 1. 1 times 2 tan squared x. This will be 2 tan squared x. So mathematically, if you check, this and that can cancel, or if you want, you can just say this divided by that, and then when you do the reciprocal, okay, not really the reciprocal, when you say, let's say for instance, you have 1 over 2 divided by 3 over 2. This can also be written as 1 over 2 times 2 over 3. This is what I'm talking about. You interchange the numbers on the other part there, and then you do the cancelling. So you can see that this 2 and that 2 is cancelling, which is just the same as this and that cancelling. Yeah, so this is what I'm saying. This part and that part can cancel. So when they cancel, we're just going to remain with, let me quickly do this. Okay, so when they cancel there, what you remain with is, when they cancel, what you are going to remain with is on top, you can say that 2 tan x and tan x will add up. So our tan 3x becomes, when we add up 2 tan x and tan x, we're getting 3 tan x, and then we have plus tan cubed x. So we say, is it plus or minus? There was a minus here. So when simplifying, we are expected to have a minus here, not a plus. So there's supposed to be a minus. So we say minus tan cubed x. And then the denominator will just remain this part, 1 . Okay, I don't know what is happening. Okay, so the denominator will just remain, let me just demarcate here, or let me erase this. Okay, so the denominator will remain as 1 minus, you can see that tan squared and negative 2 tan squared can add up to get negative 3 tan squared x. So as you can see, we have found what they wanted us to find. So they wanted us to find this, they wanted us to prove that tan 3x is equal to that, and this is what is exactly, this is exactly what we have found here. And we can therefore conclude that hence proved, we have proved. So from there, the question continues to say, hence solve for the domain for the domain that has been given. So for, the answer is supposed to be from negative 30 to 30. The equation, which is tan 3x is equal to 11 tan x. So solving this one is just the same as equating what you have found, equating your solution to 11. We equate our solution to what? To 11 tan x, and then find the answer. So we just equate the solution to 11 tan x. Okay. So we equate the solution to 11 tan x. So we say 3 tan x minus tan cubed x over 1 minus 3 tan squared x is equal to, so we equate it to 11 tan x. So when we equate it to 11 tan x, what we are going to have will simply be, so we can cross multiply here. So when you do the cross multiplication, we're going to get 1 times everything this side, we'll get 3 tan x minus tan cubed x. And then this other side will get 11 tan x times 1, 11 tan x. And then 11 tan x times negative 3 tan squared x. So this one will give us negative 33 tan cubed x. So we say, okay, negative 33 tan squared x. So from there, what we can do is we can pair the like terms. So when we pair the like terms, we can see that 3 tan x and 11 tan x, when you take 3 tan x to the other side of the equal sign, when you take 3 tan x to the other side of the equal sign, we're going to get 11 tan x minus 3 tan x. And then when we also take negative tan cubed x to the other side of the equal sign, we get negative 33 tan cubed x, then plus tan x. And then everything is equal to what? Is equal to 0. Then from there, when we add these two, we're getting 8 tan x. We're getting 8 tan x. And then when we add these two, we're getting negative 32 tan cubed x. And this is equal to 0. Yeah, so here what you can do is to factorize. So you can factorize here what is common, or first of all, we can divide everything by 8 so that we remain with tan x minus 4, tan x minus 4, tan cubed x is equal to 0. So we can factorize. So when we factorize tan x, we're going to remain with 1 minus 4 tan squared x is equal to what? 0. So from there, what we can do is we can equate tan x to 0. So tan x is either equal to 0 or 1 minus 4 tan x will be equal to 0. So this is what we're going to have here. So the other solution will come from 1 minus 4 tan x is equal to what? 0. So when you take this to the other side of the equal sign, you take 1 to the other side of the equal sign, you get 4 tan x is equal to 1. Then when you divide everything by 4, you get, when you divide everything by 4, you're going to get tan squared x. So this one is supposed to be squared. Where else? Okay. So this one is supposed to be squared. So we're going to, when you divide everything by 4, then this one is supposed to be squared. We're going to get tan squared x being equal to 1 over 4. Then when you square root both sides, plus or minus there, you're going to get tan x is equal to plus or minus 1 over 2 as the solution. So the first solution is going to come from tan inverse of 0. Yeah, so the first solution will come from tan inverse of 0. So tan inverse of 0 will simply just give you 0 degrees. So the first value of x will be 0 degrees. And then the other value of x, the other value of x will come from these two here. So we have the first one is tan x is equal to 1 over 2. The second one is tan x is equal to negative 1 over 2. So for the first one, the solution is going to be, we first have to find the reference angles and then check the quadrants. Then after checking the quadrants, you write the answers. Okay, so the first solution we found was x is equal to 0. The second solution is going to come from x is equal to tan inverse of what? 1 over 2. I've taken this one. I've taken this one here. So tan inverse of 1 over 2. So tan inverse of 1 over 2, does it exist? Is it part of the special angles? So tan inverse of 1 over 2 is not part of a special angle. So in case you've been allowed to use a calculator in an exam room, then you can take this as 26.6 as the answer. So you can say 26.6 is the answer. But if you are not allowed to use a calculator, there was a video where I showed you how to use the same thing the way it is. You just use it and apply it in the quadrants. Yeah, so 26.6 is the reference angle if you are allowed to use a calculator. So after finding this angle, I believe this is going to be the solution, because any other answer that you're going to get after testing this solution in the quadrants is going to be out of the range that you've been given, which is negative 30 and 30 degrees. So let's also try to get this. So tan inverse of that, the reference will still be 26.6. The reference angle will still be 26.6. So any other answer that you're going to get after testing the quadrants will be out of this range, and as a result, it won't be one of our answers. Okay, let's try to get for this one. Maybe that's when you believe what I'm trying to talk about, because even this one will give us 26.6 as our reference angle. So let's test for this one. So tan is positive where? In the third quadrant and the first quadrant. So in the first quadrant, the answer is 26.6. Then in the third quadrant, the answer will be what? 180 degrees minus 26.6. So once you subtract 26.6 from 180, the answer that you're going to get will be 153.4. So 153.4 is not in this range, because the range that we've been given is just from negative 30 to what? In the third quadrant, we have to add, not subtracting. So it's supposed to be 180 plus 26.6, and that is 206.6. So 206.6 is not part of our solution because it's out of this range that we have been given. Do we have any questions? Okay. So Martha is saying she has not understood on the first part. Okay, maybe let me just end the video and then I'll send it to the group as early as possible so that you quickly go through it. If you not understand it, the next time we're going to meet for mathematics, it will be the first question I'm going to solve so that you understand it again. So that you do it for the second time, and I believe you're going to understand it better. Yeah, so let me end the meeting and then, yeah, and then I'll send the video in the group.